Hello everyone. Today I'm talking about transfer floor and transfer beam in structures. What's the definition? What are the issues in structural engineering and what are the solutions? Transfer level happens when the grades of columns changing in elevation. It might be just one layer or it might be just changing in plan as well. When it is happening always in high-rise building and medium-rise buildings, we may have just in, it's very rare in low-rise buildings. In those type of buildings, we may have just one or more than one transfer floors or transfer beams. It is all to change mainly residential to commercial or residential to entertainment areas. We have generally typical floor, identical floors on top, and when we're going to change the area, application of area, or needs bigger space between the columns, we transfer the loads from the columns to new slab, new floor, and going to new columns. Here is just some view. We have just identical floors here, and in transfer level here, transfer floor here, we're going to ignore this part. It means that the loads from these columns going to be transferred to this level, to this floor, and then transferred to the columns again. And we need to have some issue to deal with the issues with this transfer. And same, we may have just RC or we may have just composite transfer beam or floor solution, and we're going to talk later. Yep, it is just typical. We have identical floors here. And in transfer floor, we have change of columns grid. We don't have the same location for the grids and we need to change. It is generally for bigger space, but sometimes it might be just some other applications as well. But anyway, we're going to transfer the loads from this column to this floor and to this columns to this floor, and then transfer to the columns until the ground and safe foundation. In this case, we say this level as transfer floor. It might be slab, or if it's just beam, we call it transfer beam. There are, in general, 4 issues with transfer floors to check. The first one is punching issue. We need to check it for the columns on the top floors and column on the bottom floors in connection with the transfer floor. We mean that we need to check for upper columns and lower columns in the transfer floor. It is very common because generally if the transfer is coming in lower levels of the building, we may have just very big loads on that one, and if there's no column under to transfer to the ground, we may have big loads, and definitely we will have some punching issues. Same concept applies for the other side. We have big loads, live loads, and just any loads here, and this column under should experience big load. So it means that we may have punching issue to the floor. The other issue is deflection. As a typical, when we change the grid of the columns, especially when we increase the space between the columns, it means that we may have bigger span and bigger deflection, and also we have big loads coming down as point load or concentrated load on the floor. It means that even if the spacing is the same, even if we keep the spacing as the upper floor, we may have big point load, and definitely we will have more deflection to deal with. Another issue that happens, this one is rare, but always remember to check. When the upper and lower columns are very close to each other. It means that we're going to have big loads transfer in a short distance. It will be a type of strut and tie issue. You know that strut and tie issue means that we may have some tension here and compression here. Anyway, if this spacing or just the distance between the upper and lower column is low, I say if it's under 1 meter, definitely go and check for transfer shear in this area, because we have big loads in a short distance to be transferred, and it is definitely a shear issue, and we may need some shear studs here, or we may need to increase the slab thickness even locally around this area. And the last issue we may have is to care about the relative stiffness of adjacent floors. If it's just one floor, we may have just change in stiffness between top and bottom floor. We can say just let's go for the other one as well. Let's say stiffness 1, stiffness 2, stiffness 3, and due to change of these elements, and we will see that the change of the slab thickness or just adding beam, we may have change in the stiffness as well, and it will change the drift issue. And if we go something for elevation, if we go for just elevation check, we may have some drift presentation like that in some codes, some standards, and we need to care about the relative stiffness of adjacent floors, and it shouldn't be big difference. Differential of the stiffness shouldn't be, in worst case, more than 10% between two adjacent floors. Some codes don't have it and some codes don't, but anyway, we need to care about that. And also for earthquake loading in these floors, floor up and floor down, definitely we will have change in distance between the mass center and stiffness center. That's a great point in earthquake loading, and we need to care about that one. So last part is the solutions. We're going to deal with big loads coming down on the slab, on the floor, or on the beam, and we need to design for that. The first one is always slab thickness. Let's say this is slab and load is coming down, and we need to transfer this load to this slab. The easiest way is to increase the slab thickness, because you know that the thicker slab means thicker section depth, and thicker section depth means better deflection capacity or better inertia capacity or stiffness capacity, and it will increase the deflection limit. It will decrease the deflection and to put the deflection limit in the area. And also it is very helpful for punching shear and shear transfer. But remember, because if in the case of concrete density is about 25 kilonewton per cubic meter, and it means that when we increase the thickness from T1 to T2, we will increase the self weight of the concrete as T2 minus T1 gamma. It is huge load. Just if we, let's say, in case of just 100 mil increase, it will be 0.1 times 25. That means 2.5 kilonewton per square meter, or kPa increase in self weight. It is huge load, and we need to care about that when we're going to have the solution by slab thickness. We're increasing the capacity for stiffness and deflection, but at the same time, we're increasing the applied dead load. The other solution is to put band beam. See, we have slab here, and we're going to transfer the column load here. So just locally, we can apply band beam under the area, especially when we have height limitations as a restraint in building, and we can't go more. So definitely in this case, so local thickening of the slab, or just let's say by providing band beam between two supports. And remember, just a band beam always should be between supports to work as a complete beam or as a complete bending increased capacity. So in this case, we have local increase of self-bear, but it's not as bad as the increasing the thickness of whole slab. This is very good solution. And the band beam is just, let's say, about 200, 300 increase, and the width is about 1 meter, 1.5 meter, 2 meter, just whatever you need. But it is much better than increasing the whole area of slab thickness. But still, always just compare between two options. Which one is better? You may have just about 50 mil increase in slab, or just about 200 locally for band beam. The other solution is deep beam adding under the transfer load. This is a very good solution because it adds huge capacity for bending, for stiffness, for the slab against applied big loads. But this one is just the main restraint for this one should be just architectural restraints. If you don't want to have or reduce the clear height between top and bottom floor, you may not be able to use this one. But if you don't have that limitation, this one is the best solution, as it is increasing the deflection and stiffness of this compound area very significantly. And that deep beam, you may have just about 200, 300 mil width and about 1 meter, 2 meter or less depth adding on this slab, and it gives you huge deflection and stiffness capacity. And at the same time, these ones and all these options gives increased punching capacity and shear capacity as well. And the last option that is very effective in some cases, post-tensioning the slab. If you are not able to change the thickness of slab, let's say if you are dealing with about 200, 300 mil slab thickness and you can't change it for any reason, an option can be just adding tendons to lift up this slab under the point load, under the increased load, and also at the same time it can give you better stiffness and punching shear capacity. Remember, you can do this one even in just one transfer floor, and you don't need to have it in all floors or identical floors. But still, there are some limitations for tendon application, and there are some limitations like if the span is over 7 meter, that is useful, or if it is under, in general we can say that tendon is not a good solution for deflection check. Anyway, we talked about issues in transfer floors, transfer beams, and how to solve that. But still, for any of these solutions, you may have just other adding or just increasing that area, like adding penetration, big opening, or just adding walls. It may all change the analysis. But anyway, just these are the general concept that is applicable for any type of transfer floor, transfer beam, and you may need to check in every transfer floor design. But remember, for complicated cases, always go for a reliable software analysis with all applicable loads. Thank you.